It says graph that. What do? Make a t-chart. Okay, is this the one where you're going to plug in numbers for x or for y? Plug in for x, okay? So if your x's, these are the ones that we just do 0, 1, 2, and then -1 and -2. So when we plug that in, here's my other question. 3 times 2 to the x. So if I put a 0 there, am I doing 6 to the 0 power or 2 to the 0 power and then multiplying by 3? Right. The parentheses are not around both numbers, so don't multiply first. Take the power first and then multiply. So 2 to the 0 is 1 times 3 would be 3. Okay, 2 to the first power is 2, then multiply that by 3. So you would get 6. 2 to the second power is 4 times 3 is 12. 2 to the negative first power, what's 2 to the negative first power? 1/2, right? Remember, you're just flipping it over. It's 1 over 2 to the first power. So that's 1/2. And then what's 2 to the negative, oh, sorry, I didn't multiply, times 3. 3/2. 2 to the negative second, 3 over 4, because then you need to multiply by 3. So you would get 3 over 4. Everyone good on that? Okay, so then you plot it. 0, 3, 1, 2, 3, 1, 6, 2, 12 is going to be way up here somewhere. -1, 3/2, which is 1.5. And then -2, 3/4 is going to be here. Make sure you draw the asymptote in. If you want to use a different color than pencil so that we can see it a little better, that's great. Or else make your line keep going so we can see where your asymptote is. And then the line itself, ooh, got a little snug to my asymptote there. Okay, questions on that? All right, number 2. How do you write that in exponential form? God bless you. 2 to the y is equal to x, okay? This is the one we were just talking about, huh? So x and y, you're going to plug in for y. If you plug in for x, it's nearly impossible to solve. So plug in for your y values. So you have 0, 1, 2, -1, and -2. When you plug in 0, 2 to the 0 power, anything to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4. 2 to the negative first power is 1/2. And 2 to the negative second power is 1/4. So you're going to plot those points, 1, 0, 2, 1, 4, 2, -1, no, sorry, 1/2 -1, and 1/4 -2, God bless. Where's your asymptote? Ooh, the y-axis is your asymptote. So you're going to draw this asymptote in. Okay, looks like that. Any questions on that? Okay. How do you know if something is a growth or decay function? It'll be the base of the exponent, right? So if you look at your two numbers here, this 1/2 is not your growth factor. Okay, it's not saying, oh, we're shrinking by 1/2. That's your initial amount. This number, whatever has the exponent with it, that's your growth factor. So if that number is greater than 1, it's what? Growth. Okay, so this one is growth. How about that second one then? Y equals 1/2 to the x power. That is decay. If this number with the exponent attached to it is between 0 and 1, so a fraction, okay, that's decay then, exponential decay. All right, number 4, write in exponential form, how would you write that? 4 to the y power equals x. 4 to the y equals x. Okay? Remember your base, the one that's down low, base, like a basement, is the base of your number with the exponent. Okay? And you're always solving for an exponent, so the standalone is your exponent. All right, here we go. Evaluate the log. If it's not possible, you're going to write does not exist. What's the question you ask yourself here? What 2 to the what power equals 8, right? You're asking yourself 2 to what power is equal to 8? What would that be? It's 3. And again, you don't get a calculator for this, so you really got to think through, okay, 2 times 2 times 2, if you don't just remember that 2 to the third is 8. So your answer here would be 3. How about this one? 8 to what power is 2? This one's harder, but if you pay attention to the problem right before it, it's helpful. What is it? 1/3, right? If you take 8 and you cube root it, you get 2, right? Well, cube rooting is the same as saying to the 1/3 power. Okay. Number 7 here. 1/2 to what power is 8? Right, so remember when you take something to a negative power, it flips it over. So that would be 2 over 1, making it negative. And we want 2 to what power to equal 8? That's 3, 2 to the third power. So 1/2 to the negative third power would get you 8. See how these are all very closely related? We're trying to get you to see like the relationship between what you do with all of them. Good? Okay, what is the base if there is no base written in? It's 10, okay? So this is saying 3 times, and this would be 10 to what power equals 10? The first, right? So 3 times 1 is what you're doing here, right? Log 10. 10 to the first power is 10. So this right here, this circled portion is equal to 1. So 3 times 1 would give you 3. So many 3s. You with me on that? Who said no? Okay. If you have log 10, think of that as this down here would be a 10, right? So log 10 is equal to 1 because 10 to the first power equals 10. 10 to the first power equals 10, right? If you put it in exponential form. So this whole thing, log 10, is always equal to 1. Well, this is 3 times log 10, so 3 times 1. Okay? All right, number 9. 3 to what power is 1 over 27? 3 to the third power is 27. What makes it drop down? A negative, right? So you would say a negative 3. Number 10. So log of 0.1. What's your base when there is no base? 10. So we're saying 10 to what power is 0.1? What's another way to say 0.1? 1/10, okay? And that might be an easier way to think of this right now. 10 to what power equals 1/10? Negative 1, right? 10 to the negative first power drops that 10 down. So log of 0.1 is negative 1. Does that make sense? All right, what's the question you ask here? 4 to what power equals 32? This is one of those real tough ones. 4 squared is 16. 4 cubed is 64, right? So that's neither of those. That's 32 falls between there. It doesn't work to just take it to some number power. So this is where we got to think through, okay, what is this number? Is it a perfect square? Is it a perfect cube? It's a perfect square. So if you think of, or you can get a perfect square out of this, if you take the square root of 4, you would get 2, right? What's the same as taking the square root? Something to what power? The 1/2 power. So 4 to the 1/2 power would get me 2. What do you have to do to 2 to get to 32? The 5th power, okay? 2 to the 5th power is 32. So you're taking the 1/2 power and the 5th power and multiplying those together, which is 5 halves. Those are fun, huh? Mind blown a little bit. So if you take 4 to the 1/2 power, you get 2, right? 2 to the 5th power gets you 32. 1/2 times 5 is 5 over 2. You multiply them together. All right, number 12. 3 to what power gets you -9? Nothing. You cannot take a number, you cannot take the log of a negative, ever. If it's log something of negative something, this number always has to be positive. If it's negative, you're going to say does not exist. Okay, can't do it. All right, how about this one? 25 to what power equals 5? What? 1/2, right? If you square root 25, you get 5. That as an exponent would be 1/2. Questions on that? Okay, so that's essentially the non-calculator portion of your quiz. Now the calculator portion. It says a radioactive material has a half-life of 50 days. Write an exponential function for a 300 milligram sample. And then part B, find the remaining amount after 145 days. Now, when you write the function, you're going to have variables in there still. When you do part B, you're going to get a number answer, okay? So let's just set up the function. Do you remember what always comes first here? Your what? Your principal, your initial amount, right? What you started with. So you're starting with a 300 milligram sample. That's going to come first. Starting with 300 milligrams. And then it's half-life. Whenever it's half-life, you need 1/2, okay? That's your decay factor. So that's going to go right here. You may write it as 1/2, or if you like it better, as 0.5, just because it's maybe a little easier to plug into your calculator, that's fine too. Either way, okay? And then the exponent. This is the one that's a little bit tricky because it's not just a number. It's a fraction for an exponent. Do you remember? You have your unknown that we're trying to find. And you have the half-life amount, the 50. Do you remember where the 50 goes, top or bottom of your fraction? On the bottom. So it's x over 50, or x over 50 if you like this setup better. I will take either one of those, okay? So that's the setup. What do you do to find after 145 days? Plug that in for x. That's your x value. So you're going to say 300 times 0.5 to the 145 divided by 50. Maybe plug that into your calculator right now just to make sure you're getting the right answer. What do you get? We'll do 2 decimal places. 40.19 milligrams. Okay, so just remember, half-life, you need a half as your decay factor. Okay, that's the one that's going to have the exponent attached to it. Yes, ma'am. It will say half-life in the problem if it's a half-life problem. Yeah. You did 300 times 0.5 to the 145 divided by 50. Okay, but make sure she sees how you put it in, so. Okay. Otherwise, when we are done with this, I'll show you. 15. An old car is bought for $7,000. Bought for oh, that doesn't make sense. We'll say and increases 3.5% in value each year. Write a function to describe the situation. Okay, so this is increase. You're growing, which means your growth factor has to be a number, what? Greater than 1, okay? Is 0.035 a number greater than 1? No. So this is where you have to be a little bit careful. When you write your function, what's the number that comes first? Your initial amount, 7,000. Okay, so your starting amount goes here. What are you multiplying by? What? Not E. This isn't the E. This isn't the E is, remember the PERT is compounded continuously, okay? You do need to know that formula for the quiz. A equals PE to the RT, but we'll go over that. 1.0, right? This is the one where you were adding 1 plus the rate. So it's going to be 7,000 times 1 plus the rate. The rate was 3.5, so 1.035. Okay, you got to add those together because we want it to be 103.5% of what it started as because it's increasing. And then to the, and time is always your exponent. So this would be your function. Okay, write a function to describe the situation. There it is. How much is the car worth 6 years from now? What do? Plug in 6 for t. So you plug in 7,000 times 1.035 to the 6th power. What do you get? It should be $8,604.79. Okay, make sure you're plugging that in to check that that's what you're getting. Questions on that? Because it says 6 years from now, what will it be worth? Okay, so number 16, similar type of problem, but it's depreciating, okay? It says a $20,000 boat is expected to depreciate at a rate of 11% each year. Write a function to describe the situation. So that's y equals, what comes first? The 20,000, your initial amount, okay, times, and now again, we're depreciating. So this one is decay, which means we need to be a number less than 1. But you have to subtract from 1, right? Because it'll be 89% of what it used to be. Does that make sense? So you don't want to put 0.11 in right here. You want to do 1 minus 0.11. So it's going to be 20,000 times 0.89 to the t power. So this would be your function. Okay. So how much is it worth 8 years from now? You're going to plug an 8 in for t, so 20,000 times 0.89 to the 8th power. And when you plug that in, what do you get? $7,873.18. Everybody getting that? Okay. Okay, this one. Notice here, that formula is on here. That formula is not on the quiz. You have to know PERT. Remember PERT. PE are normal, RT is your exponent, okay? It says, Phil invested $9,000 in an account that pays 6% compounded continuously. How much money will he have after 5 years? What do you do? So A equals what? 9,000 is your P, your principal. What's E? Is it a variable? No, it's a number, right? It's 2.17, blah, 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 blah. So E to the what? What's R? 0.06 is your rate. And then your time is 5, okay? So plug that in, 9,000 times E to the, and then make sure the 0.06 and the 5 are both exponent, right? They should be superscript. What do you get for that? Are you getting 12,000 something? $12,148.73, hopefully. How come you're not speaking to me? Yes? Yeah. Yeah, whenever you write a rate in a function, it's got to be in decimal form. Yeah, it's always going to be a percentage given to you that you then divide by 100. So move your decimal 2 places. So your E is under ln here on the left. It will give you E with the exponent already, so it'll take it to the exponent for you. Or there is an E over your division symbol, but I always use the one over here because it already makes the exponent happen for you. So you would go 9,000 second ln, and then 0.06 times, what was it, 5? You getting the right answer? Did you get it, Raven?